6.1.21-T. The following data represent the number of games played in each series of an annual tournament from 1920 to 2000. We want to complete parts A through D below. Here we have X games played, 4, 5, 6, and 7. The frequency for when 4 games are played is 14, for 5 is 10, 6 is 23, and 7 is 33. What we want to be able to do is we want to be able to construct a discrete probability distribution for the random variable x. So the first thing we need to do is we need to figure out what is the total number of frequencies, which means we need to add 14 plus 10 plus 23 plus 33. When we add them all together, we get 80. Okay? And then what we want to be able to do is we want to find the probability of each particular game played. So in order to find the probability, let's say of 4, then we take the frequency of 14, which is 14, and then we divide that by 80. Well, 14 divided by 80 is going to give us 0.175. Then we want to find the probability of 5. So we take the frequency of 5, which is 10. We're going to divide that by 80. And that gives us 0.125. Then we want to find the probability of 6. And we can see that the frequency for 6 is 23. So if we take 23 and we divide that by 80, then we get 0.2875. And then the probability of 7 games played, we take the frequency there, which is 33, and then we divide that by 80. When we divide that by 80, we get 0.4125. So now we want to then just create our discrete probability distribution. So what we do is we have our chart here, and then in our title we know that we have X, which represent games played, and then we have the probability of X. So we know that when 4 games are played, we got a probability of 0.175. When 5 games were played, we got a probability of 0.125. When 6 games were played, we got a probability of 0.2875. And then when 7 games were played, the probability was 0.4125. And so therefore there is our discrete probability distribution. Okay, now the next thing we want to do is we want to be able to graph this discrete probability distribution. So let's go ahead and graph the discrete probability distribution. So we're going to go ahead and open it up in StatCrunch. So here's our data. We're going to open that up in StatCrunch. And so here are the games played, and this is the frequency. So what we want to do is we want to change this to be P of X. So we're going to call this now P of X, and then we need to write in our probabilities that we got. So we know that we have 0.175, and then we have 0.125, then we have 0.2875, and then 0.4125. So we had to put our probability in there for us to be able to graph this using StatCrunch. So now we're going to go to Stat, select Calculator, and go all the way down to Custom. And then the values in are going to be the X, which is the games played. And then the weights in are going to be the probability of X. So now we're going to go ahead and compute. So now let's go ahead and take a look at this graph. So here is our graph. We can see that the X, which represents the games played, and then this is the probability. So here is our graph. Okay, now we want to be able to compute and interpret the mean of this random variable X. Well, the mean is already given because it's on our graph here. The mean is there. So we know that the mean is going to be 5.9375. Okay, so what does this tell us? This tells us that the mean of the discrete random variable is the average outcome if the experiment is repeated many, many times. So what we're going to say is that the series if played many times would be expected to last about 5.9 games on average. So there is our mean. And so now what we want to do is we want to compute the standard deviation of the random variable X. Well, again, we can see that it's given here. So we're going to round it to the 10th place. So we can say that the standard deviation is going to be 1.1.